Today we're going to have a look at deriving the quadratic formula, which we see over there. And that formula is used when you're trying to factorize a trinomial, but you're unable to find any combination to factorize it into the two brackets. And the reason you're unable to factorize it is because the answer is not going to be an integer. It's going to be in the form of a surd, which is a root, or you can convert it to a decimal. So in that case, we're going to need to use the formula. But very often, you also ask to derive the formula, which is kind of a bit of theory. But if you just think about taking this original general form and making x the subject of the formula, that's basically what you're doing. It's like a literal equation. Make x the subject of the formula by using all of the algebraic rules that you've learned so far, and then you will get that to become that. So let's go through the process. And you know, it's very hard to remember something, just learn something off by heart. So I always say, understand each step and what it's doing, and then you can actually just work it out. You don't have to learn it off by heart. So what we're going to do is we're going to use the method that we've been learning about, completing the square, and we're going to complete the square on this, and that will create the quadratic formula that we're trying to derive. So first of all, we don't want our constant term, the term that hasn't got an x in it, on this side. We want it on that side. So we're simply going to take it across. Whoops. And that, of course, will become negative c. And then we're going to need to divide through by a, because we can't have a coefficient other than 1 for our x squared. So this is going to become x squared plus b over ax equals negative c over a. And now, because we've got a coefficient of 1 there, we're able to complete the square on that. So we write down what we have. And then we halve this coefficient, so it'll become b over 2a. Whenever you halve something, the 2 goes into the denominator. And then we square it. So b over 2a is going to become b squared over 4a squared. Then we write down what we've got on the right-hand side. And whatever I did to the left-hand side, I need to do exactly the same thing to the right-hand side. Right, so this is now ready to be written as a bracket squared. So I square root that term. I square root that term, which means that I'm square rooting the top and square rooting the bottom. The square root of b squared is simply b. Square root of 4 is 2. Square root of a squared is a. And it will take that sign. And then at the same time, I'm going to try and simplify a little bit here. We've got two fractions being added together, and the only way we can really combine them and put them together as one fraction is if they have a common denominator. So looking at these two denominators, my common denominator would be 4a squared. So here, I've had to get a to become 4a squared, I've had to multiply it by 4a. So this will become negative 4a, and the c is already there, plus b squared. Now I want to square root both sides because I don't want to have a bracket squared. I just want to have what's inside the bracket. So let's just put in orange what our thought process is. You don't have to include this into your actual proof, but a lot of people like to do that just to keep themselves on track. So if I'm square rooting something that's squared, I'm just left with what's inside the bracket. Now, at the bottom of this fraction, I've got 4a squared, which is a perfect square. So I can square root it, and the square root of 4 is 2, and the square root of a squared is a, as we've seen earlier on. But all of this is not a perfect square, so I can't square root it. So I need to still leave it in the square root bracket. And just to tidy it up a little bit, I'm going to put the positive value first and the negative value second. It means exactly the same thing, it just looks tidier. All right, so the other thing to be careful of here is that we need to consider the positive or negative value of the square root. So we won't get our two answers for x. When we use this, we won't get our two answers for x if we only consider the positive square root. So we have to consider the positive and the negative, and that will give us our two values that we normally get for a quadratic equation. So all I need to do now to isolate my x is to take that to the other side. And now I'm going to do two steps in one. Do you notice that they've got the same denominator? So I can write everything in the numerator over the denominator of 2a. I can combine it because they've got the same denominator. When this goes to the other side, it's going to become negative. So I've got negative b from this, plus minus, I can't simplify this, b squared minus 4ac. And if we have a look at that, it's exactly what we have over there. And so we've taken our general form of our quadratic equation. We've simply completed the square on it, following all the rules that we learnt in the previous episodes. And we've come out with the quadratic formula. So if you're asked to derive the quadratic formula, this is what you're needing to do. And in future videos, we'll see how to actually apply it to a question.